Okay, what we're going to do now, the next step in our journey, is we're going to apply the normal distribution. Okay, earlier I said, if you remember, that there is a special distribution that we can use and convert all normal distributions to that one distribution. And we called it the standard normal. If you remember, I used the symbol N for normal distribution with mean 0 and standard deviation 1 to represent the standard normal distribution. Now, we picked that one because it was the easiest to work with, and we can convert every normal distribution in the world to this one. This happens to be the one that we've been learning to read. So now we can apply this. Now, one thing is, how do we convert to that? That's the only thing we're missing. In this equation, it may look difficult. You might not like to see the square root of 2 pi or e, but this is a really nice equation. Right here is where the magic takes place. Right there. So I'm going to write this down. Z equals x minus mu over sigma. This calculation right here computes any normal distribution, the mean of that distribution. You plug in the mean of that distribution here, you plug in the standard deviation there, and you will get z values that are on this table. That will convert it. That piece of that big, nasty equation. So, what's next? Let's work some problems. Give me a second to put some on the board, and we'll start doing this. Okay, I have a problem up on the board. A couple things I did is there we go. I got it set like I like it. Okay, notice I kept the title up here, applying the normal distribution, and I kept this equation here that we're going to use. Now, I set up a scenario. Suppose the mean volume of Pepsi in a 20-ounce bottle is 20 with a standard deviation of 0.05. So the two numbers that we're going to be concerned with, standard deviation, the mean volume in a 20 is 20. That's the mean, that's the standard deviation. Those are the two numbers we're interested in. Okay, so let's look at what's going on here. What is the probability the next bottle you purchase has less than 19.985 ounces in it? So I'm going to draw a picture. There's the mean is 20. 19.985 is to the left of that. And we're wanting less than that. So we shade in the area to the left of that. That's what our normal distribution, that's the area of interest that we're going to deal with. That's our area of interest. Okay, so let's use the formula. And I'll show you what happens. Z equals, okay, mu comes from the problem. It's 20. Excuse me, I'm lying to you. Mu comes from the problem. It's 20. But you write it at the mu spot, not at the x spot. Sorry, I wrote the wrong spot. Sigma comes from the problem, net 0.025. X is what particular value we're interested in. 19.985 equals. Okay, if we do the math, what we get there is 19.985 minus 20 divided by 0.025, and we get negative 0.6. Okay, what that means is this value is equivalent to, and I'm going to change colors. I'm going to make this red, negative 0.6. That's the z value of negative 0.6 on the z table. What would happen if we plug in 20? 20 minus 20 would be 0. Wasn't 0 the mean of our standard normal distribution? This 20 represents 0. This 19.985 represents 0.6 on our z-table. So we look it up. And I have not done this. Done this negative 0.6. We get 2743. 0.2743 is what we get. So that's going to happen 27% of the time under these conditions. Under that much deviation, much variation in your product, in your quantity, that's going to happen 27% of the time. Okay, let's look at this next one. Same type thing, 20's in the middle. What is the probability the next bottle you purchase has more than 20.04? 20.04 to the right of the mean. And it says purchase has more than that number. More. There's more right there. So what do? Well, we use our formula. 20.04, the number we're interested in, minus mu, which comes from the problem, over the standard deviation, which comes from the problem. We find out that number there. That's what we compute. So if we type that in, clear, and we get 1.6. So in this case, we have an upper tail problem. So we're going to have, and what does the table give us? It gives us the lower area. We're going to need to take 1 minus this area to get our answer. So we're going to have 1.0000 minus, we look up 1.6, 9452. 10 minus 2 is 8. 9 minus 5 is 4. 9 minus 4 is 5. That happens 5% of the time. Not very often, 5% of the time. Now, and I'm out of room here, what I'm going to do here, I guess I could try to squeeze it in. You see what's going on. Actually, I need more room. What I'm going to do at this point is I'm going to free myself some room. Okay, so I'm going to work the problem up here. So we have a curve. Upper boundary was 20.05. The lower boundary was 19.95. And that's what we're going to do. So I'm going to have two z values. When you're doing in between like this, I like to do the z of the bigger number on top and then the smaller number on the bottom. It makes the answer flow a lot better. I'll show you what I mean. We take 20.05 minus 20 over 0.025. 19.95 minus 20 over 0.025. We find out what these values are. Okay, this is 2, and this is minus 2. So, continuing on, we look at 2, look at minus 2, and I had done that previously, I think. Maybe not. Well, I'll look it up, no big deal. 2.9772 and negative 2.0228, and that's 0.9544. Okay, now what I mean by this works out real nicely. You look these two numbers up. Well, you calculate these two numbers. You look these up, and then they're already in position to subtract. And there's your answer sitting right there. That's how you apply the standard normal distribution to any problem out in the world. That's how it's done. Okay, let's pause there for a moment.